In this video, I'm doing 1.2 real numbers notes. This is a continuation of 1.1 real numbers notes. This will be happening in the first week of school. You need the same materials as you did before, printout of the notes, pencil, calculator, and 2 different colors. Okay, so here are the notes. Start by just putting your name on them. My name is Miss Lynn. Whatever period that you have me, the date, this is happening in week 1 of school, and then your practice assignment. There is not a practice assignment for 1.1 real numbers notes. Okay. Here is your standard below, same standard as 1.1 real numbers notes. Starting with our key vocab on the left, real numbers, as we learned before, can also be positive, negative, or 0. There's 5 categories. Those categories are rational numbers. Those are our fractions, decimals that stop or repeat. Integers, those are the negative, 0, positive numbers. Whole numbers include 0. Natural numbers start by 1. They just go up. Those are our counting numbers. Irrational numbers, you think of 2 things. You're either thinking of pi or the square root of a non-perfect square. Okay, so the main thing we're doing today are properties of real numbers. I'm going to make this a little bit bigger. And we're just going to go down the list. Commutative property of addition. Okay, I want you to write A plus B equals B plus A. Commutative property, you're going to think switch order. I'm just going to write switch order. Associative property of addition. This involves parentheses. I'm actually going to put parentheses here. Make a note whenever you think associative property, think parentheses. So if I have the quantity A plus B plus C equals A plus the quantity B plus C. Notice what happened here is I switched, or my parentheses moved, I should say, from the A plus B to the B plus C. That's called the associative property of addition. And then I'm just going to make a note here. I'm just going to say regroup. Okay, regroup. Additive identity. I want you guys to write here. The additive identity is 0. The additive identity is 0. Okay. In other words, A plus 0 equals A. So you're thinking what number, or what can you add to a number to yield the same result? Okay, the only thing you can add, for example, 2 plus what equals 2? Okay, 2 plus 0 equals 2. Additive inverse. I want you to write here the additive inverse of A is negative A. The additive inverse of A is negative A. Okay. Additive inverse, you're thinking, what can I add to a number to get 0? So A plus negative A equals 0. If we put this in real numbers, what do I add to 2 to get 0? Well, 2 plus negative 2, or 2 minus 2 equals 0. Okay, that's our properties of addition. The bottom half of our table is properties of multiplication. Very similar. So commutative property of addition, we switched order. Commutative property of multiplication, we're going to be doing the same thing. We're going to be switching the order. It's just going to be multiplication now. So I want you guys to write A times B equals B times A. Commutative property, I'm just switching the order. Okay, I'm going to write that again, switch order. Associative property. Again, associative property of addition, I told you to think parentheses, it's the same idea. Now it's just with multiplication. So the quantity, or parenthesis, A times B, and parenthesis, times C, equals is the same thing as A times the quantity, B times C. Okay, I didn't change the value. That's what that means. I just shifted my parentheses. It did not change the value. And then again, we're going to write the word regroup. Okay, multiplicative identity. So the additive identity, we were asking ourselves, what can I add to the number to yield the same result? Now you're going to ask yourself, what can you multiply to a number to yield the same result? I want you to write here the multiplicative identity. I'm going to shorten it. Multiplicative identity is 1. Okay, the multiplicative identity is 1. This means A times what number gives us A? That's going to be A times 1. Okay, A times 1 still gives us A. Or think about that in real numbers. 2 times what equals 2? Well, 2 times 1 equals 2. Multiplicative inverse. I want you guys to write here the multiplicative inverse. And again, I'm going to shorten the word multiplicative. Of A is 1 over A. The multiplicative inverse of A is 1 over A. Okay. So the idea here is A times 1 over A equals 1. Okay, that one's a little bit confusing. You're just thinking inverse. Okay, so if I put A over 1, remember inverse, you're flipping that fraction to be 1 over A. Last but not least, the distributive property. So if I have A times the quantity B plus C equals, the distributive property here just means I'm distributing A to both numbers. Okay, this equals A times B plus A times C, times there. Okay. So those are our new vocab words for today. Make this big so you guys can see it all. All right, let's look at example 1. Classifying numbers, we have a graphic organizer here. So place 5, -5, 1/5 in the square root 5. We're going to mark which sets, okay, they belong. Remember, something can belong to a multiple set. This goes back to what we did in 1.1 notes. 5 is a whole number, which means it's an integer, which means it is rational. Okay. If something's rational, you guys, it can't be irrational. If something's irrational, it can't be rational. -5 is an integer, rational. 1/5 is a fraction, that means it is rational. Square root of 5 is a square root of a non-perfect square, therefore it is irrational. Or if you guys type this into your calculator, you'll get a really long decimal that goes on and on forever. Moving down, example 2. This talks about closure. This says a set of numbers is closed under an operation if the result of the operation on any two numbers in the set is also a number in that set. Closure is a little confusing. Just kind of write this down, let it wash over you. I don't expect you guys to totally grasp this concept right away. Closure is tricky. Okay, so real numbers are closed under addition. This means a real number plus a real number always equals a real number. Okay, I want you to put yes here. It is closed under addition. Real numbers are also closed under subtraction. A real number minus a real number always yields a real number. Yes, they're closed under multiplication for the same reason. And yes, they are closed under division. Think about division. Whenever you divide two things, like 5 divided by 4, that gives you a fraction, right? All fractions are real numbers. All right, irrational number. Irrational number plus irrational number can sometimes be a rational number. That means it is not closed under addition. An example of that would be like the square root of 2 plus negative square root 2 equals 0. Irrational plus irrational equals a rational number. Same reason, irrational numbers are not closed under subtraction. Irrational numbers are not closed under multiplication, and they are not closed under division. Rational numbers are closed under addition, they're closed under subtraction, they're closed under multiplication, they're closed under division. Integers are closed under division, closed under subtraction, closed under multiplication. However, they are not closed under division, because I can say 2 divided by negative 5, that doesn't equal a negative whole number or a positive whole number. I guess you could say that's a fraction, which means it is rational. Just going back, I did make a mistake on the real numbers. Real numbers encompasses everything. So whatever number we talk about this year in Algebra 1, they are all real. So just think real numbers are closed under everything. And again, this is a little confusing. Just take it for what it is. Don't read too much into it. Which of the statements is true? A, the sum of two rational numbers can be irrational. The sum of two irrational numbers can be rational. The product of two rational numbers can be irrational. The quotient of two rational numbers can be irrational. Take a moment to think over this. The correct answer here is B. The sum of two irrational numbers can be rational. For example, negative square root 2 plus square root 2 equals 0. We have an irrational plus an irrational equals a rational number. Under which operation is the set of integers not closed? Look at our table. Integers are not closed under division, okay, because that gives us a fraction. We can have negative 3 over 2. This is a fraction. It's rational, but it is not an integer. Okay, last two examples. These are very similar to what we did with 1.1 notes. Complete the addition table. Write all numbers in decimal form. Okay, before we do this, something a little bit different I want to do here. Let's go ahead and automatically write if our outside numbers are rational or irrational. I'm going to put an R here. This is rational, rational, rational. Square root 3 is irrational, negative square root 3 is irrational. Same thing up top. Rational, 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 irrational, irrational. So same thing like we did in 1.1 notes, you guys are adding. So for example, 4 plus 4 is 8. 4 plus 1/4 is 4.25. Okay, I'm going to pause the video, take a moment to go ahead and complete this table. Okay, here's my completed table. So same thing we did yesterday, we're going to color code our rational, irrational. I think yesterday I made rational yellow, put R for rational, and I made irrational pink. So I'm going to start with my yellow. I'm going through, I'm just color coding my rational numbers. So it's this whole box here. right? And we talked about this yesterday. A rational number plus a rational number is always rational. This whole box is rational. Oh, whoopsie. I made a mistake here. Sorry, it's this whole box. It's 3 down and 3 across. Irrational plus rational. Notice these are always irrational. So this whole box here, I'm going to color code in pink. And then irrational plus irrational. I'm going to do my rational first. It's sometimes rational. Oops. Because we do get 0. 0 is a rational number. And it looks like the rest are irrational. So I'm going to make this pink. Okay. Alright. Same thing down here. Now it's the multiplication table. Same idea. Again, I'm going to start by writing this is rational, rational, rational. This is irrational, irrational. Rational, 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 irrational, irrational. This is multiplication. For example, 4 times 4 is 16. 4 times 1/4 is 1. 4 times 0 is 0. I'm going to pause the video, take a moment, and fill out this table. Okay, here's my table. Again, I'm going to start with my yellow for irrational. I'm sorry, yellow for rational. Yellow's rational. So this top box here, looks like it's 3 by 3 is rational. I'm also going to do all of my zeros, right? All of the zeros are rational. Then it looks like I have a group of rational numbers in this bottom corner. 3 and -3 are rational. My irrational numbers are what are left over. Okay, so what does this tell me? A rational times a rational is always rational. Rational times irrational, sometimes irrational, sometimes rational. Irrational times irrational. This one happens to be always rational. That's not always true, but this one is. Okay. And then irrational times rational, we got sometimes rational, sometimes irrational. Okay, those are your 1.2 notes.